Hello everyone, welcome to the course on operating systems. In the previous session, we have discussed about the different types of operating systems, including batch operating systems, multi-programming operating systems, multi-processing operating systems, and multitasking operating systems. In this session, we are going to discuss about 4 other types of operating systems, including time-sharing operating system, distributed operating system, network operating system, and real-time operating system. So in case of time-sharing operating systems, there will be one host computer and there exist different terminals which are having a relatively lesser computational capability, and they'll be using the services or the computations from the host computer. So this kind of operating system is called as time-sharing operating system. That means the CPU of the host computer is switched between different terminals in order to serve the requests from these terminals. So a time-sharing operating system enables concurrent use of the computer by multiple users. That means there exists only one computer, but because of the time-sharing operating system, there can be multiple terminals connected to the same computer and they'll be able to use one single computer parallelly. And here processor time is shared among multiple users simultaneously. Coming to the advantages and drawbacks of time-sharing operating systems, here users which are located at remote terminals can access the single computer simultaneously. That means though they can be located at different places, they'll be able to use the computer parallelly. And it avoids duplication of softwares. Since all the terminals are using the same host computer, whatever the softwares that are required for executing different applications on these terminals need not be installed separately on different computers, but they can be present in only one host computer. And it is cost efficient because since the hardware as well as software is shared by multiple terminals, the cost is less. And coming to the drawbacks, there is a communication overhead. That means each time whenever a process has to be executed by any of these terminals, then the request has to go to the host computer and the host computer performs the computations and sends the results back to the terminal. So due to this, there is a communication overhead between the host computer and the terminals. Since the data is communicated between the terminal and the host computer, there is a security concern, which is that means the communication, since the communication is involved, it is not so secure. So it is one more challenge in case of time sharing operating systems is to ensure the security and integrity of user programs. Integrity means if a request goes from the terminal to the host computer, in between it should be ensured that the request is not being modified. So that is called as the integrity, maintaining the integrity of the user programs. And examples of time sharing operating systems include terminal services offered by the Windows Server. The next type of operating system is a distributed operating system. Here, various autonomous computers interconnected by a communication network. So here you can see in the diagram, the database server, file server, and there exists a workstation and terminal. All are connected to a communication network. That means file server in a file server can be used for storing of the files and storing and retrieving of the files. And similarly, there is a dedicated database server whose responsibility is to maintain the database. So other computers need not have the file storage or they need not maintain the databases. So for each specific task, there is a dedicated server in case of a distributed operating system. Each computer possesses their own memory unit and CPU. and the remote access is enabled. That means different devices can access the services from the different types of servers using the communication network. So here the applications are distributed across multiple computers, and also the operating system services like file management, database management, they are also distributed across different computers. Example of distributed operating system include banking applications and also the railway reservation application. Coming to the advantages, it allows remote working since we are able to access different types of servers from different places. It allows remote working, and the exchange of data among the users is relatively faster, and failure in one site does not cause any disruption in the system. That means if one server fails, it does not cause disruption. Generally, in case of distributed operating systems, there exists redundancy. That means not just one file server, there will be multiple file servers. So even if one file server fails, still the system won't be disrupted from operation. And it minimizes the load on the host computer. So each computer need not maintain the database, need not maintain the files. They can access these resources from different servers. They minimize the load on the host computer. Coming to the disadvantages, if the primary network fails, the entire system shuts down. That means since all these servers, workstations and terminals are interconnected through the communication network, if the communication network fails, then these devices will not be able to access any of the services from these servers. And as compared to the other operating systems, installation of distributed operating system is very expensive. And it requires a high level of expertise also to maintain the distributed operating system. And examples of distributed operating system are Amoeba and Google distributed systems. The next type of operating system is networked operating system. Here, the primary focus is on managing the network related operations and services within a single computer. So for example, if you consider the local area network in an organization, there will be a server and there will be different clients, and also there will be different kinds of resources, including printers also. They'll be interconnected through a network. So here basically the machines can share the resources. That is one of the application of networked operating system. And one more application of networked operating system is you can maintain the network connections or the network related operations of all these computers that are connected in the LAN using a single computer, that is the server. So it's the network operating system design is to facilitate communication within a local area network. Coming to the advantages, since there are centralized servers, they are highly stable. So instead of maintaining the network related operations in different computers, it is just sufficient to manage all these network related operations in a single machine, that is the server. And if at all the softwares that are used in the organization have to be upgraded, or whenever a new technology or a new hardware has to be installed, in such a case, that needs to be done only on a single server, not in the other machines, because whatever the new softwares that are being installed in the server can be accessed by all the clients that are connected in the LAN. And in using networked operating system, we can access servers from remote locations. And coming to the drawbacks, the servers are relatively costlier as compared to the ordinary personal computers or desktop PCs. And one more disadvantage is dependency on a central location for most of the operations. Since all the network related operations are being managed by a single server, if the server fails or if the server is compromised, then the entire LAN will be under security breach. It needs regular maintenance and updates. Examples of networked operating system include Microsoft Windows Server and Linux and Mac OS X. The next type of operating systems are the real-time operating systems. For example, aviation or the health applications or robotics. In such kind of applications, whatever the data that is being generated has to be collected in real time and has to be processed. So real-time operating systems are suitable for such kind of applications. And RTOS, in short, real-time operating systems are called as RTOS. They are used in environments where a large number of events must be accepted and processed in a shorter time and within a stipulated time. So, whatever the data that is, for example, consider the example of a heart rate monitoring. So, in such a case, whatever the physical signals that are collected from the patient have to be immediately displayed on the screen. So such kind of applications do not tolerate any delay in processing. And there exists different types of real-time operating systems, including hard real-time and soft real-time operating systems. So in case of hard real-time operating systems, the deadlines or the timelines are very critical. So they guarantee that critical tasks are completed on time. And here the secondary storage is limited or missing. So whatever the data that is being collected in real time has to be processed immediately. So there is no need to store the data that is being collected, because the storage and retrieval and processing again takes, it consumes more amount of time. So hardly in case of hard real-time systems, the data is stored in the RAM. So it has to be immediately collected and processed. That is why the secondary storage is almost missing. And examples of hard real-time systems include medical imaging systems, industrial control systems, weapon systems, robots, air traffic control systems, etc. Coming to the next category of real-time operating systems or RTOS are soft real-time systems. They are not that much time critical. So soft real-time systems are less restrictive. Soft real-time systems have limited utility than hard real-time systems. So generally real-time operating systems means we need to process the data as and when it is being collected. So there should not be any delay. So only such kind of applications are said to be real-time applications. So soft real-time systems are they are not that popularly used. Examples of soft real-time operating systems include multimedia, virtual reality, advanced scientific projects like undersea exploration, etc. So in all these applications, even if there is some amount of delay in processing the data, it will not cause much damage or the applications can still run. And coming to the advantages of real-time operating systems, since they are dedicated, real-time operating systems are designed generally for performing a dedicated task. For example, heart rate monitoring or aviation. So in such cases, the applications are limited. That means the number of processes that have to be run by the CPU are limited. So maximum utilization of devices and systems, and the task switching overhead is relatively less, because it will not perform any other task other than the designated task of the real-time operating system. In this case, there is not much switching between the processes. That is why it is relatively the context switching is minimized. Coming to the disadvantages, the algorithms are very complex and difficult for the designer to write. That means here the operating systems have to be so efficient that they have to capture the data in real time, and once the data is captured, they should be able to process it within the hard deadline and give the results without any errors. So the algorithms that have to be used along with the real-time operating systems are relatively complex. And examples of real-time operating systems include Windows Server, Oracle Solaris, and Mac OS Server. So they also can be used for real-time applications. So with that, we have completed the discussion on the different types of operating systems. We'll meet again in the next session. Thank you.